Hi guys, today we are going to be working on our 5-1 algebra proofs. And these are our notes, the very first set. This is the first time you've probably seen proofs, but you have done these types of questions before. Now we're just going to articulate what each step means. The learning intention today is I will learn how to use properties to prove algebraic and geometric problems. Okay, we have a ton of these proofs or proof properties that's what they're called, and as you see, they are in bold. So addition property of equality says if A equals B, then A plus C is equal to B plus C. And what that means is if I give you a algebra problem, so let's just do an example. Say for instance you have x minus 5 is equal to 3. And I asked you, how would you solve for x? Well, you would add 5 to both sides, and you would get x is equal to 8. Okay, that's addition property of equality. Or, let's say, for example, I give you x plus 5 is equal to 3, and asked you, how do you solve for x? Well, you would subtract 5 to both sides, and you would get x is equal to negative 2. So the addition property of equality is when you add or subtract to both sides. And that's your addition property of equality. Okay, moving on. If we did multiplication property of equality, it states if A equals B, then A times C is equal to B times C. So, for example, let's say, for instance, I said 2x is equal to 6. And then asked you, how do you solve for x? Well, you would divide by 2. So x is equal to 3. Okay? Or, let's say I have x over 2 is equal to 6. And asked you, how do you solve for x? You would multiply each side by 2, right? So x would then be equal to 12. Okay? So the multiplication property of equality means when you multiply or divide something to both sides. All right? So we have the addition property of equality and the multiplication property of equality, and then we also have the symmetric property of equality. That says if A equals B, then B equals A. So say, for instance, you solved your equation and you got, so let's do this backwards. Here's my example. Say I have 6 equals 2x, and then I solved for x, so I divided by 2. Well, then that states that 3 is equal to x. But the proof is that, let's say, for example, the proof wanted me to say x is equal to 3. So I would use the symmetric property and saying, well, if 3 equals x, then I can flip it and say that x is equal to 3. Okay, so symmetric property is flipping what side x is on. Then I have transitive property. Transitive property states if A equals B and B equals C, then A equals C. A good example for this is, let's say, for instance, that x is equal to y and y equals 3. Okay? Then I can say if x equals y and y equals 3, they share y, so then x is just equal to 3. And so the transitive property, the conclusion of that is that when three things equal each other, okay. We also have the substitution property. It states if A equals B, then A can be replaced by B. So a good example, let's say that X is equal to 2. And you have an expression that says, well, I know that 2x plus 5. There's my expression, 2x plus 5. How would I simplify that expression? You would substitute in what x is equal to, so x is equal to 2, so that would substitute in, and I would have 2 times 2 plus 5. So that would be 9, okay? So substitution is like in a game, we substitute in a player for another player. Same example, we substituted a number in for a variable. Distributive property, let's have an example, like 2 parentheses x plus 6. If we use distributive property, you would multiply 2 throughout your quantity of x plus 6. So that would give me 2x plus 12. Okay? So we have 6 properties today: addition property, multiplication property, symmetric property, transitive property, substitution property, and distributive property. And we will use these to help us solve algebra equations and proofs. All right, let's go ahead and start off our very first proof. Given d is equal to 20t plus 5, I am trying to prove that t is equal to d minus 5 over 20. So based off of what we were given and what I'm trying to prove, we can then say that I am trying to solve for t. Okay? And as you get better at these, you will really then begin to figure out how or what you're solving for. So the step 1 is always what we were given. You just copy down what it says. So d is equal to 20t plus 5. And you always call it given. Okay? If I am solving for t, the very first step I need to do is subtract 5, right? So my step 2 would be d minus 5 is equal to 20t. And the question you have to ask yourself is, what did you just do? Well, you subtracted 5. Which property, when I subtract 5 to both sides, would that be? That would be the addition property of equality. So we abbreviate this as addition property of equal, which means of equality. And I will say of equality, but I will always write of equal. Okay? We're still having to solve for t, so I'm not quite done, right? So 20 is next to t and it's being multiplied to t, so how would you get rid of 20? You would divide by 20 to both sides, right? So step 3 is d minus 5 divided by 20 is equal to t, because those 20s cancel, right? And then you state, what did I just do? I divided by both sides, and then you go back and you look at all of your properties and you say, which one is division? Well, the multiplication property of equality. So multiplication property of equality. Okay. And we're not quite done, because if you notice, the t is actually on the left side, where right now I have it solved for the right side. So using the symmetric property, I can flip-flop what's on each side of the equal sign. So I have t is equal to d minus 5 over 20. And now it looks exactly like the proof. It has to look the exact same at the end, otherwise we are wrong. And that is called symmetric property of equality. And we are finished. Okay? All of you guys are used to doing the algebra for step 1, 2, 3, and 4, but we aren't used to identifying what property we used to do that. So that's what proving is. You're proving what steps you're using to solve for the question. All right, let's go ahead and move over to the second example. The given is 8x minus 5 is equal to 2x plus 1, and I'm trying to solve for x equals 1. So I'm solving for x. And that's something that we need to identify before we begin our proof so we know where we're trying to reach at the end. Okay, step 1. You write down the given always exactly as stated. So 8x minus 5 is equal to 2x plus 1. And that is given. Here you'll notice we have variables on both sides and we have numbers on both sides. So there's going to be multiple ways to solve it. I'm going to show you one way, but you might solve it a different way. So I like to move the smaller variable over, so I'm going to subtract to the 2x. And step 2, that's going to give me 6x minus 5 is equal to 1. And then I subtract it to both sides, so when I subtract, that's called addition property of equality. Okay, and then I'm solving for x. So from this step, I know I need to add 5 to both sides. So step 3 is 6x equals 6. Well, I added to both sides. So again, it is addition property of equality. Sometimes they repeat themselves, and that is okay. All right, the last step is I divide by 6. And so step 4, well, the 6's cancel, so I'm left with x is equal to 1, right? And I divided, and that is called multiplication property of equality. And if you notice, x equals 1, the x is on the left side, so I don't need to use symmetric property to flip-flop what side the x is on. So I am done. These are my 4 steps, and I have given my 4 reasons. Okay, let's go ahead and finish the back to proofs. And here's really where we're going to dive into that geometry concept with algebra. So it's not too different, it just starts off a little different. The given is that DF is congruent to EG, and I need to prove that X is equal to 10. Okay? So DF is congruent to EG, and I need to prove that X is equal to 10. So I know somehow I'm going to have to create an equation and solve for X. So step 1, we write the given. DF is congruent to EG. That is given. Okay. Well, what do you notice about DF? Well, DF is equal to 11. And what do you notice about EG? Well, EG is equal to 2x minus 9. So if they're congruent, that also means they are equal. I can use something called substitution. So substitute in what DF is. So DF is 11, and that equals EG, and EG is 2x minus 9. And what did I just do? What property from the front? I substituted in something for something else. So that's called substitution property. Okay? And from here I know I need to solve for x because that was my proof. So step 3, what do I do here to solve for x? I'm going to add 9 to both sides. Step 3, I get 20 equals 2x. And I added to both sides, so that is called addition property of equality. okay? And then I'm still solving for x, so I need to divide by 2. And so my step 4 is going to be 10 is equal to x. All right, and I divided, and so the division is called multiplication property of equality. And it doesn't quite look exactly like my proof yet. So if you notice, the 10 and the x are on opposite sides. So I need to flip-flop it so it looks exactly like the proof. And when I flip-flop it, I get x is equal to 10. That checks out. And that property is called symmetric property of equality. And you guys will get like a cheat sheet of properties that you may use for your tests and your notes and any quiz or anything you might have. So don't be concerned if you have to memorize all those properties. You will have a bank of properties for all of those homework assignments and tests. Okay, we have our last one. So step 1, angle Z is congruent to angle Y, and that is given. Again, if you look at the proof, it says x is equal 100, so I know I'm going to have to come up with an equation to solve for x. So I'm going to go look at my picture, and I notice that angle Z is 2x minus 90. So I'm going to substitute that in for angle Z. I have 2x minus 90, and congruent means equal, so it equals, and then angle Y is x plus 10. And since I plugged in something for something else, that is called substitution property. Okay, I'm solving for x, and you'll notice kind of like the front that, again, we have variables on both sides. So this question has multiple ways to solve it. So if yours is a little different, that's okay, but I'm going to show you one way. I always like to move the smaller variable, like I said at the front, so I'm going to subtract x to both sides to start me off. So step 3 is x minus 90 is equal to 10. And I subtracted to both sides, so that's called addition property of equality. Okay. And I'm still solving for x, so my next step is I need to add 90. And I get x is equal to 100. And look, it matches the proof. So I am done here. And since I added 90 to both sides, that again is going to be addition property of equality. Okay, and that is the set of notes for 5-1. Don't be discouraged when we talk about proofs. I realize that they look a little bit intimidating, but we are going to get really great at these. So just keep trying, and if you need help, come in and ask a math teacher for help. Have a good day, guys.